How you doing, Sioux High Earth Science students? This is Mr. McLeod again with our next astronomy podcast. Today, we will finish our discussion of the phases of the moon and then begin to talk about eclipses. You should see by now that eclipses and moon phases are definitely related. So get your notes out, something to write with, and let's start finishing. Well, finishing moon phases, that is. We'll actually be starting eclipses. So finish starting, start finishing. Oh, well, you know what I mean. Okay. So we're going to finish the moon phases. So we've finished our waxing phases, which are down here. Now we're going to work on our waning phases, which are up here now. So we're going to actually start with a full moon, because we ended with the full moon, and we're going to make our way eventually back to the new moon. Okay, the appearance of a full moon is the finish of what we call the waxing phases of the moon. Now we enter the waning phases, where we begin to see less and less of the moon. You should see that right in this diagram. A waning gibbous moon appears over the eastern horizon in the hours between sunset and midnight. Write that down. So waning gibbous appears over the eastern horizon in the hours between sunset and midnight. So here's our waning gibbous. Here's our picture of a real waning gibbous. Now the moon is past full now. Once again, it appears less than full, but more than half lighted like it would here in the last quarter. Now, because it comes up at night, the waning gibbous moon prompts people to start asking, where is the moon? They say things like, I looked for it last night and couldn't find it. Now, in the few days after a full moon, you'll often see the waning gibbous moon in the west in the early morning. Write that down. So in the few days after a full moon, you'll often see the waning gibbous moon in the west in the early morning. And it'll be floating somewhere against the pale blue sky. Okay. Now a last quarter moon, and here's our last quarter moon right here. A last quarter moon looks half illuminated. So what we mean is if the full moon is fully illuminated, then half means you can see half of the lit face. Now, a last quarter moon rises around midnight and appears at its highest at dawn, and then sets around noon. Write that down. So rises at midnight, at its highest at dawn, and sets around noon. So write that down. Now the name last quarter moon has to do with the fact that if you look at the entire circle, our first quarter is a quarter revolution. Our full moon is a half revolution, so sometimes you'll hear the full moon called a half moon, which is really confusing. And here's our next or our last quarter. This is the last quarter turn before we get back to the new moon, so write that down. Timing-wise, the last quarter moon comes about 3 weeks after the full moon. Write that down. Now, the moon in its orbit around the Earth is at right angles. You can see that, at right angles to a line between the Earth and the sun. So from this diagram, the sun's over here because it's lighting up the face here. So it's at right angles to the sun. It's at right angles. Also write that the moon is now 3/4 of the way around its orbit. Make sure you get that in your note, as measured from new moon to the next. Now, after the last quarter phase, the moon will begin edging noticeably closer to the sun on the sky's dome. Write that down. So full moon is its furthest away. Remember we said the waxing gibbous was nearly as far away from the sun as the moon can get? Well, now the moon is heading in its orbit toward the sun. Now, fewer people notice the moon during the day from about last quarter on. Now, why? Because the sun's glare begins to dominate the moon. Write that down. So fewer people notice the moon from about last quarter on because the sun's glare begins to dominate the moon. And why is that? Because now the moon's getting closer to the sun. Now, a waning crescent moon is sometimes called an old moon. Now, if you remember a waxing crescent down here, that was called a young moon. Well, now we're all the way over here at waning crescent. So waning crescent would be about as old as the moon can get in this cycle. That's why we call it an old moon. Now, the waning crescent is seen in the east before dawn. Write that down. It's seen in the east before dawn. Now here's what that means. Each morning before dawn, because the moon is moving eastward in its orbit around the earth, the moon appears closer to the sunrise glare. So if it's closer to the sunrise glare, we see less and less of the moon's day side. Write that down. Now, because we see less and less of the day side, the crescent in the east before dawn appears thinner each day. And you can see how thin it is here. So remember, we're seeing progressively less and less of the moon. So it appears thinner each day. Now, the moon, as always, is rising in the east day after day. But most people won't see this moon phase unless they get up really early. Remember, they got to get up before the sun comes up over the horizon. Then when the sun comes up and the sky grows brighter, the waning crescent moon fades because it's now covered by the sun glare. Now the moon is so near the Earth's sun line that the sun's glare is drowning this slim moon from view. So you'd have to get up really early to see the waning crescent. So if you look up in the sky and see a crescent, it's more than likely a waxing crescent because the waning is so difficult to see. Okay, and now we are back to the beginning, meaning back to the new moon again. Remember, this is a cycle, meaning it happens each month. However, the timing is different each month because of the 50-minute difference between the Earth's rotation and the moon's revolution. But enough about moon phases. Let's start talking about a phenomenon called eclipses. Once again, this is a topic most people think they understand, but in reality, not many people really do. However, when we're done, you will. So here we see a picture, and you're going to see lots of different pictures in the upcoming slide. But here on the left is what's called a lunar eclipse. You can tell a lunar eclipse because obviously it's the moon, but it's also that pinkish red glow, and by the size it looks in the sky. Where here on the right now is a solar eclipse. Totally different. You got the sun in the background here, so a completely different phenomenon and a completely different reason. So what we're looking for now is the positioning of the Earth, moon, and sky for each. So let's tackle it. Okay, first of all, the word eclipse means to block out. Get that down in your notes. So the word eclipse means to block out. Now, there are two basic kinds of eclipses, and we need to get those general descriptions in your notes before we talk specifics. Now, since we just finished talking about the moon phases, let's discuss lunar eclipses first. Remember, the word lunar means moon. So if you don't have that in your notes, get it in there now. Now, it's important that you remember that the moon's orbit path is tilted 5 degrees with respect to the orbit path the Earth takes around the sun. Remember, we call this wobbling. We use the example of a seesaw or a teeter-totter. And because of that phenomenon, we can have a full moon with no eclipse because the moon is either above or below the Earth in relation to the sun. If you need to review that in your notes now, please do. And here is another diagram of the difference between the moon's orbital plane and the ecliptic plane. You might want to get that in your notes. The ecliptic plane, which is the path that the Earth travels around the sun, is called the ecliptic plane. And you can see how the ecliptic plane is flat and that the moon's orbital plane is tilted about 5 degrees. I know we already talked about that, but it's worth reviewing it before we start talking about eclipses. Now, the big difference occurs during a lunar eclipse. In a lunar eclipse, the Earth is directly in line and in between the sun and the moon, like you see here in this diagram. So here is our Earth, here's our moon, and here obviously is the sun. So we have the Earth now between the moon and the sun. I'd like you to get this diagram in your notes as best you can and label it correctly now. Now, you should also recognize that because the moon is at its furthest point from the sun in a lunar eclipse, it can only occur at full moon. Write those two things down. The moon is at the furthest point from the sun, therefore a lunar eclipse can only occur at full moon. Write that in your notes. Now take a look at the diagram you see here, and you'll see a couple of new terms we need to understand. The first is the word umbra. You see the word umbra right here. The umbra is the darkest part of the shadow the Earth casts on the moon. Write that down. So the umbra is the darkest shadow the Earth casts on the moon. Also write that the umbra is a region where the Earth blocks all direct sunlight from reaching the moon. So write that down. The umbra is the region where the Earth blocks all direct sunlight from reaching the moon. And you can see that here. You can see right here in the umbra, this dark brown part right here, all the light is being blocked now by the Earth from the sun. We call that the umbra. Next is the penumbra. So here's the word penumbra. You see a penumbra here, and you see a penumbra there. It's just not labeled. Now, the penumbra is the cone of shadow cast by deflected light. Write that down. So the penumbra is the cone of shadow cast by deflected light. Also write that the penumbra is a zone where the Earth blocks part, but not all, of the sun's rays from reaching the moon. So get that down as well. The penumbra is a zone where the Earth blocks part, but not all of the sun's rays from reaching the moon. That becomes important because what you see is completely different if you're standing on the Earth looking at the moon in the umbra rather than in the penumbra. So the question becomes this: if we have a full moon every month, why don't we have a lunar eclipse every month as well? You should know the answer to that by now. So write an explanation for this question in your notes right now. Let's see how you do. Okay, if you said that the moon isn't always in the Earth's shadow because it wobbles in its orbit path because of the 5% difference, and therefore isn't always in the same plane as the Earth, you'd be correct. Remember that diagram we just looked at. Okay, so when can we see lunar eclipses then? The moon passes through both the umbra and the penumbra in stages. Write that down. The moon passes through both the umbra and penumbra in stages. Now the initial and final stages, that is when the moon is in the penumbral shadow, are not so noticeable. Write that down. So the initial and final stages, the initial would be up here, the final would be down here. When the moon is in the penumbral shadow, really difficult to tell. Now the best part of an eclipse, a lunar eclipse, is during the middle of the event, when the moon is in the umbral shadow. Also write that down. So here's our umbral shadow. So that's the best part of a lunar eclipse. Total lunar eclipses, also called umbral eclipses, write that in your notes. So total lunar eclipses are called umbral eclipses, and you just saw a diagram of why. These are kind of a freak of cosmic happenstance. Ever since the moon formed about 4.5 billion years ago, it's been inching away from our planet by about 1.6 inches or 4 centimeters per year. Get that in your notes. What's cool is the setup right now is perfect. The moon is at the perfect distance for the Earth's shadow to cover the moon totally, but just barely. Billions of years from now, that won't be the case. Write that down. Now, during a total lunar eclipse, the Earth's full umbral shadow falls on the moon. That's really important for you to understand. Write that down. During a total lunar eclipse, the Earth's full umbral shadow falls on the moon. Now, the moon won't completely disappear, but it will be cast in the Earth's eerie shadow that makes it easy to miss if you are not looking for the eclipse. Now, in this diagram, you're seeing a bunch of pictures now of the lunar eclipse now. Here's the interesting part, and I want you to write this down. If you were standing on the moon looking back at the sun, you'd see the black disk of the Earth blocking the entire sun. But you'd also see a ring of reflected light glowing around the edges of the Earth. Now that's the light that falls on the moon during a total lunar eclipse. How cool is that? Don't just sit there, write that down. So if you were standing on the moon looking back at the sun, you'd see the black disk of the Earth blocking the entire sun. But you'd also see a ring of reflected light glowing around the edge of the Earth. Now that's the light that falls on the moon during a total lunar eclipse. So if we take a look at this diagram, we see all of the stages of a lunar eclipse. And you can see the moon now being eclipsed. If we move left to right here, this is the Earth's shadow now. The person who took this was obviously in the umbra. You see the shadow increasing now from the Earth on the moon. Now, these pictures are pictures of the penumbral shadow. And you can see a complete difference here. Now, let's talk about the blood red moon. The moon may turn red or coppery, and you can see it here in these pictures, during the total portion of an eclipse. Write that down. So the moon may turn a red or copper colored during a total portion of an eclipse. Now let's explain why that is. The red moon is possible because while the moon is in total shadow, the Earth's shadow, some light from the sun passes through the Earth's atmosphere and is bent towards the moon. Write that down. So the red moon's possible because while the moon is in total shadow, the Earth's total shadow, some light from the sun passes through the Earth's atmosphere and is bent toward the moon. Now, while other colors in the spectrum are blocked and scattered by the Earth's atmosphere, red light tends to make it through easier. Also write that down. Now the final effect is to cast all the planets' sunrises and sunsets on the moon. Now lastly, the penumbral lunar eclipse. This is the least interesting of the eclipse because the moon is in the Earth's faint or outer penumbral shadow. Unless you're a seasoned sky watcher, you likely won't notice that effect. Write that down. So what that means now is that you're looking at pictures in this slide of umbral lunar eclipses. And you now know why you're seeing different colors. But remember that it's the Earth's shadow that's being cast on the moon. Okay, now on to solar eclipses. Take a look at the position of the sun, moon, and Earth in this diagram. They're all labeled on the bottom. I'd like you to reproduce this diagram as best you can in your notes now, and make sure now to include the umbra, which is this dark triangle right here. This is the umbra. And these lighter blue triangles are the penumbra. So take a little bit of time and reproduce this diagram. So these blues are the penumbra, and this dark spot in the middle is the umbra. Okay, now an eclipse of the sun is referred to as a solar eclipse. You know that the word solar, anytime you see it, means sun. Now what I'd like you to write down is that a solar eclipse can only occur at new moon when the moon passes between the Earth and the sun. So if you look at this diagram now, in a lunar eclipse, the moon was all the way over here on this side. Now it's between the sun and the Earth. This would be a new moon phase. Okay, but remember now, keep thinking about that diagram of the 5% difference between the orbital plane of the moon and the orbital plane of the sun. That comes into play here as well. So if the moon's shadow happens to fall upon the Earth's surface at that time, we see some portion of the sun's disk covered or eclipsed by the moon. Again, get that in your notes. So if the moon's shadow happens to fall on the Earth's surface, we see some portion of the sun's disk covered or eclipsed by the moon. Now, a lot of it depends on where you're standing on the surface of the Earth. Now, since the new moon occurs every 29 and a half days, get that down if you don't have that timing in your notes. The new moon occurs every 29 and a half days. You might think that we would have a solar eclipse about once a month. Well, that would be great, but unfortunately, this doesn't happen. But I'll just bet you can explain why, right? Do that in your notes right now, and let's see how you did. If you said it's because the moon's orbit around the Earth is tilted 5 degrees to the Earth's orbit path around the sun, once again, you would be correct. Now, as a result, the moon's shadow usually misses the Earth as it passes above or below our planet at new moon. Write that down. But at least twice a year, the geometry lines up just right so that some part of the moon's shadow falls on the Earth's surface and an eclipse of the sun is seen from that region. So write down that it only occurs twice a year, about twice a year. Because the moon is casting its shadow on the Earth, that shadow also has two parts to it, just like the Earth's shadow did. So let's get these down. First is the umbra. And we know now from your diagram, the umbra is this little triangle right here in this picture, is the umbra. This is the dark inner shadow that the moon casts on the Earth. Now, write down that total eclipses are seen from within this shadow. Total eclipses are seen from within this shadow. Now you can see here, it's a very small portion of the Earth. That's why when solar eclipses occur, a small percentage of the people on the surface of the Earth can see them. So you can clearly see why viewing a total eclipse is so difficult. The umbra is really small. So the track of the moon's shadow across the surface is called the path of totality. Write that down. So remember, let's take a look at what we mean by the path of totality. If you're standing right here on the umbra, the Earth isn't sitting still, it's still rotating. So this little swath is rotating as well. So you would be rotating and be able to see it, but only if you're in that umbra. It's typically 10,000 miles long, but only 100 miles wide. So write that down. So the swath is only 10,000 miles long, but it's also only 100 miles wide. And then there is the moon's penumbra. That's these two blue triangles, which is the faint outer shadow. Now, in the umbra, you would see a total eclipse. If you're in the penumbra, you would see a partial eclipse from within the shadow. Write that down. So right here in the penumbra, you'd see partial eclipses. So here's a picture of a partial solar eclipse. Now you can see the moon passing between the Earth and the sun. So here's our moon passing between the Earth and the sun. This means that the person that took this picture was standing in a penumbral shadow the moon casts on the Earth. Much greater chance of standing in a penumbral shadow than in the umbral shadow. Also notice how the moon looks about the same size as the sun. Do you remember why? Write that down in your notes. Now, if you said because of the difference in distances, you'd be correct. Remember, the sun's way bigger than our moon, but it's 93 million miles away, whereas the moon is about 1/6 the size of the Earth, but it's only 246,000 miles away. So they look about the same size in the sky.